This week on Quality Digest Live, a cake maker offers a sweet lesson on standardization.
Plus, what do Yugoslavia, IG Toyota, and an Italian auditor have in common? We'll find out when we come back.
Welcome back to Quality Digest Live for November 8th, 2013. QDL is your weekly look at who and what is making the news in the world of quality. I'm Mike Richmond, publisher of Quality Digest.
That's it, and I'm Quality Digest Editor-in-Chief, Dirk Ducharme. Well, we've all seen pharmaceutical ads on television. You see at least one or two or three per television show during prime time. Lots of money spent pushing drugs at you, the consumer, right?
Sure.
Well, that's nothing compared to the amount of money Big Pharma spends advertising to healthcare professionals, according to the FDA. That's because that's where it makes the most sense. You might not ask for a prescription drug just because you see it on a television ad, but certainly you might not question it if your doctor prescribed it, so they are the ones that are targeted. The type of advertising that is directed at healthcare professionals has the FDA a bit concerned, so they have launched an e-learning course and case studies as part of its Bad Ad program. The program is designed to raise awareness among healthcare professionals and students in various healthcare programs about drug ads, promotional materials that might be untruthful or misleading, and more important, how to report them to the FDA. By the way, it's not just for healthcare professionals or students. Anybody can take the Bad Ad course. It's free. It's not just for healthcare professionals. The case studies are pretty interesting if you follow the link on our story. The case studies cover a range of promotional materials, including a website, a journal ad, and a television ad, and touch upon numerous promotional practices that don't really comply with FDA regulations. And here's the thing, the case studies are real. I went through a couple of them. They're not just kind of, Acme Corp.
Yeah.
These are actual case studies from real pharmaceutical companies that got in trouble with the FDA, and it includes the warning letters that were issued by the FDA to the company. So the material actually tells you what to look for in advertising, and actually tells you how to report it to the FDA if you see something that you think is misleading. And gives you actual case studies and how the FDA responded to those actual cases. So if you're interested in this, it's interesting even for consumers. There is a link to the course in the article down below.
Right down there. Great.
Yeah, right down there.
Okay. Well, next up, an engineer, a designer, and a business major walk into a classroom. The teacher looks up and says, "Is this a joke?" Okay. So that's a joke.
Sort of.
It's a bad joke, but it's a joke. But actually, it leads to a really interesting news item we ran this week from MIT News called The Course for Making Things. According to this piece, MIT has launched an interesting and rather unique course in product design and development, in which class members are broken out into 6 to 8 person teams. Now, there's nothing new there, but here's the unique part. Each team consists of at least one engineering student, one student from the Sloan School of Management, and one student from the Rhode Island School of Design, which is partnering with MIT in this class. The benefits of such cross-disciplinary teamwork are obvious. In real-world situations, of course, product launches are the brainchildren of many people from many different areas of the organization.
Sure. Yeah.
It happens all the time. These students, therefore, are learning, even before their careers really begin, the value of different perspectives in bringing products to market.
I like it.
I like it too. They've learned that lesson so well, in fact, that by the end of the semester, it can be difficult for observers to tell which school individual team members emerge from. And that's the goal, according to MIT professor Warren Searing, the man who teaches the class. They want the students to really learn from one another and absorb those unique perspectives. They learn, therefore, a lot about compromise, trade-offs, and picking your battles in this way. And that's really what it is, because you're trying to mimic the real world, and that's really how it works. I mean, you don't have engineers in a bubble that don't have to think about what the salespeople need to do and the design folks. I mean, it all kind of works together.
Right.
This past spring, the teams made their final presentations, and some really fascinating products emerged, from a device for predicting avalanches, to a mask decorating kit for hospitalized children, to a sponge especially designed to steam clean the insides of microwave ovens. I think that's really cool. Many of these product launches ended up launching companies too. The avalanche detector and the mask kit are now offered by startups that sprung from that very class. So good stuff there. So for more information on this news item, and in fact all the pieces that Dirk and I are going to be covering on today's show, just click on the story links just below the video screen right down there.
I mean, that makes a lot of sense. I mean, it's nice doing that actually in school, because typically you learn your discipline and you go out into the workplace and all of a sudden you realize, oh, hey, I have to actually work with other people.
That's right. It's good practical advice there from that class.
Right. Well, is standardization a hindrance to improvement or to innovation? That was actually the question asked by one of our Indian columnists, Arun Hariharan, in a two-part article that he offered up over the last couple of weeks. The first part of the article was really just setting up kind of a scenario. It happened to be a true scenario. A friend of his grandmother, when Arun was going to school here in the United States, she was an older woman, very firm, as he puts it. Also very rotund.
Good for her.
But she was a great baker. I mean, she made all the baked goods for her church.
Everybody loved it.
Everybody loved it. Yep. She sold some of her baked goods at a local supermarket, and they would just fly off the shelves.
Classic thing. You have something that you create on your own without even thinking about anybody else. You just do it because you love it and you're great at it. And what happens? It just takes off. Right?
It takes off.
Right.
Well, it took off so much that her family said, you got to go bigger with this. Make this into a business. And she kind of resisted for a while, but eventually she gave in, and with the help of her family, many of whom came from manufacturing, she scaled up her production, and over the course of 3 or 4 years ended up with 8 factories, hundreds of workers, and 4,000 or 5,000 retail outlets for her products. And her products, according to Arun, were pretty darn close to what came out of her oven at home. And the reason they were able to do that was standardization. Basically, she communicated to her family members and eventually to the factory workers what the process was. Obviously, it was scaled up for a manufacturing size, but this wouldn't have been possible without standardization. Now, nobody questions this. We know how important standardization is, but a lot of people also make the argument that one of the problems with standardization is that it squelches innovation.
Creativity.
That you've got this standard and it's cast in stone, and if I have an idea, I can't do anything with it because we've got this this thing written in stone. And Hariharan says, hey, no, that's not the case. And in fact, you need standardization as a platform upon which to build innovative ideas. And he has this great quote from Ford, if we can put that up. This is from Ford, Henry Ford. Today's standardization is the necessary foundation on which tomorrow's improvement will be based. If you think of standardization as the best you know today, but which is to be improved tomorrow, you get somewhere. But if you think of standards as confining, then progress stops. That's Henry Ford. And if you think about it, this makes a lot of sense. Suppose you had a factory, and in that factory you were making something, and you had multiple factories, and they all made that something slightly different. The output was maybe the same. The quality could have been consistent among the factories, but they were made different. So if somebody in factory number 1 comes up with an innovative idea that will improve the quality of the product, so he calls up factory number 2 and says, hey, if you just go to this step and make this change, it's going to improve the product. They're going, what step are you talking about? And no, the step right after you pull things out of the oven, and no, we don't do it that way. So how do you communicate this improvement to other facilities if they're all using a different standard? You don't have a way to communicate. If everybody's using the same process, then you simply, you have a change order to the standard, to the process instructions that say at this point, you do this differently. That now becomes the standard. And so now you've inched the improvement of that product up across the board, and it's written now in stone. So how do you go about doing this? Well, the first thing you have to do is you have to have a format for documenting your process, how your process works. Now, there's a lot of ways to do this. Arun outlines one in his article, but he says, it doesn't really matter what that format is for documenting as long as you have it consistent across your facilities and how you document. He says you just got to make sure you collect the important information. You want the process steps, the controls, who is the process owner, performance measures, output, stuff like that. As long as that's all contained in your format for your flowchart or however you're mapping your process, it doesn't matter what that format is. Now, how do you get those process steps down? And this is where it's important. You don't depend on the manager. You don't depend on the inventor necessarily. You go to the floor and you see how that product is currently being made by the people who are making the product. This assumes that your product is being made to a standard that you appreciate at the moment. And you have them tell you how they make the product. Or you watch them and you write down how they make the product. And you create your process flow based on what you're actually seeing on the gemba, on the shop floor, as related to you by the people doing the job. And Arun doesn't add this step, but I will. As soon as you write that down, you then go back and watch that process being done and verify that what you were just told is actually what's going on, because people accidentally leave out steps. You do that across the entire facility, and now you have your standard. So now what? Your standard's in place. Well, every now and then you want to audit to the standard, and this is where the beauty of this comes in. You want to go out and you want to make sure that people are doing the job properly. So you go out there and you watch them and you make sure, okay, yeah, you're doing it to the standard. You may see somebody who's doing something different. Well, they're either doing it different and that's a bad thing, or they're doing it different and you ask them why and they say, well, I discovered a faster way to do this. You did. Well, show it to me. And it turns out they're right. They have just innovated. They have innovated the process. They probably should have communicated it to somebody, but they innovated the process. Now you're seeing it, and it's a good idea. So now you change the standard. The standard now becomes something that implements this innovation. By the way, innovations can come from anywhere, but no matter where they come from, they get implemented in the standard, rolled out across the organization, and that becomes your next platform. See, this is the thing. People think of standardization as the 10 commandments. They're written in stone, never to be changed. But they aren't. A standard is a living document. And so what you do is you take your standard and you just keep inching it up. You keep building it up. Next innovation, change the standard. Next innovation, change the standard. And you continue to raise the level of quality and service across your entire organization built on a standard that's a living document.
Yeah, and a couple things. I think that the idea that it's going to evolve, that there's going to be, like, you'd almost call it mutations in the process. But that you're going to look at those, and you're going to analyze those as they go is really key. Is really key to the feedback loop here. And the other thing I think is really important is that, you know, this is the reason why document control is such a huge part of ISO 9001 as an example, and why we talk about document control so much. Because when you have that process, now that you've got it iterated and you understand what it is, you've got to make sure it's controlled. You've got to make sure that everybody can have access to it, knows where to find it, so they can refer to it, whether they're a new worker or somebody maybe just wants a refresher. I mean, you've got to be able to access that information at all times. And again, however you do it doesn't really matter. The tools are less important than the idea, the culture of how you're going to do that within your organization.
That's right, and that's why, by the way, that is actually one of the things people point to of something like ISO 9001. It really, if you use it right, it really is a platform for building good, solid quality processes and inching them up.
Yeah, and this whole idea that standardization, that the misunderstanding people have that it's a shackle, it prevents you from innovating, is, I think Arun puts it beautifully, it's the platform in which you can innovate, but you've got to be able to communicate first. You've got to know what is the baseline before you can start changing those things.
That's right. Good story. Arun's a good writer.
Really good stuff. Check that out. Check that two-part story out. Okay, another really good story. Again, this is International Week here on Quality Digest Live. From another one of our columnists, Italy's own Umberto Tunisi, who wrote an article called
Quality Philosopher.
Toyoda's Way. Umberto Tunisi, that appeared in yesterday's issue of Quality Digest Daily. And this one is, as Umberto tends to do sometimes, it's kind of a lesson in history, as well as a lesson in quality. And he starts with the passing of Eiji Toyoda, who died at the age of 100 a few months ago. We covered that here on the show. And Umberto was ruminating on Eiji Toyoda's life and his passing recently. He was also reading a book at the same time, which was talking about the post-World War II history of Yugoslavia. And you kind of think about that and say, well, where's the connection there? Well, I'll tell you where the connection is there. The book referenced a Skopje, hopefully I'm pronouncing this properly, Skopje Imperial Tobacco Manufacturing Company in Macedonia, which exceeded its 5-year plan in 1947 through the efforts of Tsvetan Ivanov, who was referred to as an exceptional leader, and Boris Tanaskarov, who was considered to be a rationalizer.
Really, Ivan and Boris.
Yes. Now, there's no truth to the idea, the rumor, that the bottleneck they were overcoming was the meddling influences of Moose and Squirrel.
Moose and Squirrel.
No, that's not true. But those two guys really pushed it forward within that particular plant. Now, like Eiji Toyoda, as Umberto's ruminating on, like Eiji Toyoda, these two men worked with what they had available at the time. Now, remember, 1947, Macedonia, post-World War II, Eastern Europe wasn't in great shape, so there was a lot of difficulties, a lot of bottlenecks they had within their process, both their human capital that they had to work with and the material capital as well. So they were able to eliminate waste and improve productivity despite these lack of resources. And in the case of the Macedonian tobacco manufacturers, they did it through what the book refers to as assault workers, and that's translated. So I'm not sure exactly what in the Italian this would be, but assault workers who are individuals who help to raise the quality of the workforce through helping those individuals read and write. Many of them couldn't read and write at the time, and then helping them and the organization as a whole understand and communicate the benefits of mechanization. Because again, you were going from kind of an agrarian culture at that point to a more mechanized culture in the workforce. That's basic stuff, but it was necessary given, again, what they had to work with, and it was effective as well. The point of all this, as Umberto says, is that quality world needs to learn lessons. It only learns lessons when they're forced to, many times. It's not that you choose to learn these lessons and adapt these things, but you're forced to do that through circumstances. And
in their case, it was the lack of the lack of resources.
The lack of resources, the lack of skilled labor, sure. and all these things that combine. Now, I think it's important to understand the forces that forced that forcing was World War II, right? I mean, World War II, in my mind, still was the defining event in modern human history. And everything that we've come to in this point, economically, politically, socially, I think has come from that war, from that event in the last century. And really what it did is it forced all the nations of the world to reevaluate where they were, especially in the manufacturing sense. Because I've mentioned this before, and it's common knowledge, I think, for most people, that America really, after the end of that war, was the only industrialized nation really still standing in many cases. I mean, Europe, Asia were all kind of leveled, and America really never got bombed. I mean, America was kind of, even though there was losses, was standing alone. And American manufacturing in the 40s and the 50s and even in the 60s kind of had an open field. I mean, there was no need to be efficient. And the lack of efficiency, you could even maybe call it the laziness, began to proliferate in American manufacturing, and especially in the car industry we saw it, where they didn't have to be efficient. They didn't have to worry about waste because they're pretty much selling everything and they were making huge profits, so they didn't worry about it. Now, in Eastern Europe, certainly in Japan with AG Toyota and Toyota Motor Company, they had to be very efficient. They learned the lessons of efficiency and lean that America knew in a prior era before the war, when Henry Ford was on the scene, where they had to be more efficient. You know, in the early part of the 20th century, America wasn't dominant like that, like they were in 1945. So we understood it in this country, got away from it, whereas the Europeans, the Asians kind of knew it after the war, and I think that's the ramifications of that. We're still feeling that today, and I think that's what Umberto's talking about in the story is working with what you got, making changes when you have to, but maybe thinking about the fact that you need to make changes even when you don't have to, as America probably needed to in the 40s and 50s, to not get in a circumstance where, like the American auto industry has been for the past several decades. So good story. Umberto understands the auto industry a lot. He talks about the auto industry as he's audited to that often in Europe. And
you have to read the Umberto sometimes can be a little difficult to read because he's more of a philosopher. I would say, and so you have to kind of read his articles slowly and a couple of times. But there's really some nice stuff in
really
there. This one in particular,
good lessons there. So check that out again. All that story is below the player page down there. You can check it out and read it at your leisure. Okay, well, we're going to move on now because we have a great tech corner here that Dirk is going to do with Rob Bellinger of Olympus, and Rob and Dirk have done a few tech corners together, and we're going to do one now on the Olympus stream. So guys, take it away.
Yeah, thanks, Mike. Yep, so once again, we're here with Rob Bellinger of Olympus. Hey, Rob.
Nice
thanks for joining us. Yeah. So we're going to we're going to concentrate more on software today rather than hardware, right?
Yes, so Olympus has had for a few years now the Olympus Stream software. This is our analytical software package running with a digital camera on any kind of industrial type microscope. It could be from a stereoscope to wafer inspection scopes, as long as they can attach a digital camera and utilize the software. The Stream software is focused on industrial applications, so I'm going to show you some of the new features in our latest version 1.9 and some of the improvements that we've made to it. We're constantly taking in customer requests and customer pain points and improving the software to
when
meet those
you
needs.
say industrial, what kind of industries are we talking about?
Industries, they range from metal manufacturers, looking at surfaces and roughnesses and grains analysis and stuff like that, to semiconductor, medical device manufacturing, a big range of any kind of manufacturing where they want to take critical images and measurements on their samples.
Okay.
So today the Stream 1.9 software, some of the quick things I'll cover, some of the new features. The software does incorporate a very integrated database tool. And there are several new features that I can't cover all of them in the time we have, but some of the new features for the database tool, so like copying fields and being able to paste them quickly into new inserts and stuff. But I just wanted to cover the database. Database allows archiving of your images and measurements and reports that are generated, and to be able to search through them quickly later and share throughout the network of users in the company, I would imagine.
Okay.
Back to our acquisition screen. Stream has a workflow process to streamline the process. So you start with the database, you take acquisition, you capture your images, you process the images and create reports.
So similar to some of the other software I've seen from Olympus, you've got tabs, or you've got a way to kind of work your way through the process visually, right on the screen. Okay.
Yes, exactly. Yeah, there's a
corner.
workflow process to everything to make it simplified. The screens can be customized and simplified for use for different levels of users even. So different people log in. Beginner users could have very simplified screens. The engineers could have more screens that they're going to interface with. Real quickly though, some of the quick stuff that you use is manual measurement functions. And down here on this bar, we have a lot of different manual measurements that have been in the software forever. Line width measurements, angle measurements, area measurements. Those can all be done manually on a picture that's taken. We've added a couple new features to this. We got feedback from customers. A lot of customers wanted to be able to do circle-to-circle length measurements. So we have that new feature in the manual measurement toolbar. We can come out here and mark 3 points of a circle and move over and mark 3 points of the circle that you want to measure the length to. And
so now it's showing the length right there on...
showing the length right on the image, and all of these manual measurements can be exported to a workbook, then out to Excel or embedded into reports, transferred right into your PowerPoint.
So it's storing this also onto a table in the
software
right down
here.
There. Okay, yeah, so your features pop up down there. Okay.
So we also put in a new angle ruler. This allows you to bring a ruler out onto the screen and determine specific angles of things. So that's some of the manual measurements and add-ins that we've added from feedback out in the field of use of the tool. Capture new live image. We also added the feature, a lot of customers requested we put a vertical scale bar on the image. So now we not only have a horizontal, but we can add a vertical scale bar.
And what's their usage for that?
The usage of this is when you capture an image and they email the image off or archive it, they want to be able to open it later and know that it's calibrated to a certain size. Okay. And this size, even if you print it out, doesn't matter. You can go off of this scale here and know the exact dimensional measurements of what's on the image. Okay. So I mentioned real quick about the PowerPoint. That's a new feature in the software as well. We've always been able to take our reports and all of our measurements and workbooks and send them right to a Microsoft Word document. That's great for archiving, sending out as PDFs. But a lot of customers were asking, they were creating presentations in PowerPoint. Okay. So now we have a built-in toolbar interface in PowerPoint where we can send images directly, captured images directly into a PowerPoint presentation you're working on, workbooks right into the PowerPoint, and modify those images directly in PowerPoint and be able to save those PowerPoint presentations right back to your database once it's done. One other new feature added on the screen for live quick measurements is a digital reticle.
Oh, that's cool.
A lot of customers ask for this where they can be on a live image like we are.
Now this scales as you change zoom factors and so forth, or lenses or whatnot?
Exactly. So if you're integrated with the microscope, which our software integrates with a lot of our scopes, like this one here is coated nose piece. As soon as you change objectives, it's going to modify and change the scale on the screen. We also have a new, with a motorized stage like we have on here, the ability to click and, click to center kind of function.
So you just clicked.
All I have to do is
clicked on a point.
Control and click on a point, and it'll move that directly to center for me. So if we were quickly wanting to measure this box here, we could just put it in between the reticles, touch it up a little bit. We know it's about 200 microns width. This is a way for them not to have to take pictures and manually measurement, just quicker. Drive to the points, move it in between the reticle here, and get a measurement.
Now, is that shifting the image, or is it actually driving the stage to that point?
This is actually driving the stage to that point, so we can keep going and bring anything we want to the center of the field of view by clicking and centering.
Ah, interesting. Okay.
So the digital reticule,
I'm sorry, and the reticule is calibrated when the system is calibrated?
Yes.
So they know the reticule is accurate. If they measure something with the reticule, it should be...
So during software install, you're going to put a standard, usually a traceable type standard on here. You're going to calibrate the software. And all of your measurements, the digital reticle, the scale bar, everything is based on that calibration.
Okay, so measurements are traceable. Okay.
Yeah. Turn that off. Some of the features in the software, we have material solutions in the Stream software. These solutions are kind of packaged and individualized for certain custom uses in the field. For industrial applications, we have like grains analysis for metals and cross sections where they want to measure grain boundaries and grain patterns and widths. We have layer thickness measurements for cross sections of materials where they have layers that they want to measure.
Okay.
We have metal inclusions. Certain manufacturers of different types of metals want to measure their inclusions. So all of these porosity measurements, all of these solution modules are designed specifically for an application.
Can you show us a couple of those? Or?
Yeah, two of the new ones that we added to Stream 1.9 are automatic measurement and coating thickness. So automatic measurement is just that. The software can actually take a motorized stage and drive around and take automatic measurements of patterns. These patterns can be repeatable in different areas. There might be something where the customer is looking at a pattern and they want to take it off, process, like polish or do something else to the sample, put it back on and move right back to that. Built into all of these solution modules now is a stage path function with an alignment feature. So we have the ability to put a sample on anywhere on the stage, move to a point of a known pattern and align it with 3 points anywhere on the sample, and that aligns the position and the rotation.
Okay.
So then you can repeatedly drive back to those points after processing and take some automatic measurements. I'm going to go through that in a second and show you a quick example. Coating thickness is another new solution module. That one allows us to measure coatings that are put on the surfaces. So a lot of times metals will put like a coating for surface matte finishing, and they'll want to take and measure those thicknesses. That can be done here. And I'll show you that as well. So automatic measure, we'll start a routine here real quick. This routine is going to run through. I have this in more of the manual mode right now. It's not the fully automated mode, just so I can show how it functions in a little bit slower reaction for the demonstration here. What it's going to do on the screen here, it's going to look for a specific pattern that I defined beforehand. And it's going to take several measurements for us. It's going to take a width measurement, an angle measurement. It's going to measure some circle distances and stuff. And that's all done by a button click. It's going to automatically define the pattern, mark the scanners for us, mark the line edges. It's going to give us a width measurement. It's going to give us our angle measurement. It's going to give us our distance between the circles here and the diameter of the other circle down here. So another thing real quick, we can see okay and not okay. So we programmed in tolerances.
Okay, so you can program in do your inspection at the same time. Okay.
So with these tolerances, it's a quick visual inspection that it's passed. If it didn't pass, maybe they need to take the sample off and do more processing to it. Now they'll probably move to several new points on the sample. And you can see that this new point, it's close enough, it's within the field of view, the pattern's there.
So it'll automatically find it.
It's going to automatically find that pattern for us and mark all the measurements again.
Show us the layer thickness measurement. That was, you were showing me that earlier. That was pretty interesting.
Sure. Let me finish this real quick. We'll mark the last pattern. Okay. One thing to mention, on all these solution modules, when you're finished, you'll get kind of a workbook feature showing all of the measurements and your tolerances. These can be sent right out to Excel or your reports or PowerPoint.
Okay, so you can export right now. Matter of fact, that looks a little bit like an Excel spreadsheet.
Yeah, it's a workbook, and we just hit an Excel button here, and it lets us save out as an Excel document.
Okay.
Or we can go right to our reporting tab and generate a Word document with this embedded into it.
Or this could also be a PowerPoint?
It can also be sent into the PowerPoint document. Yeah.
All right.
Yeah. Let me go back to you wanted to cover the coating thickness.
Yeah, the coating thickness.
I have an image here, real quick. I'll load. So this is an example of a surface that's been used a grinding ball of a certain diameter, grinds through the coatings. And this one has two individual coatings you can see here with the bands. We can measure this thickness since we know the exact diameter of the grinding ball and how many coatings we have. So we'll go into that module.
So I can see there's like an outer ring that's kind of a lightish gray color, and then an inner ring, and then you've got the actual base material.
Okay. Exactly. So all of these solution modules, they work as a workflow, just next kind of buttons. They all give you instructions at the top. We hit next here. We can type in a lot of information for our samples. Customers are usually going to have hundreds of these pictures that they'll want to process through, and this solution module can batch process those. All of our solution modules can do batch processing. And we hit next here. The settings for this, we can work on a flat image. We can also work on cylindrical or concaved. We just need to select what kind of material we did this work with. This one was a flat one. We type in the number of coatings. We type in the diameter of the grinding ball. And we just hit next. And then it's going to physically ask us to mark the first outer layer. So we'll mark 3 points around that outer layer. Okay? And then we can move ourselves into the inner layer and then the last bottom base layer. And once we mark those 3 points, which is 2 layers, it'll give us our coating thickness over here. Again, if you had 100 samples, you could quickly go through these and get an idea. If it was a reject, you could just reject it out of the process. We just hit next to get our results. And again, just like all the other solutions, we hit finish and we get a nice workbook up here with all of our result and data.
That you can export. That's great. We're almost out of time. Anything else you want to touch on real quick?
One more thing, the Stream 1.9, the new version, if customers currently have them, it is upgradable. If they want to upgrade their older build of the software to the 1.9 and incorporate these, any of the solution modules can also be purchased and add in at any time to our software package.
Okay, terrific. Okay. Again, that was the Olympus Stream, right?
Stream, yes.
Okay, Rob, thanks a lot.
Yeah, thank you, Dirk.
Back to you, Mike.
Thank you, Dirk. Thank you, Rob. Yes, the Olympus Stream 1.9, and another great tech corner there with Rob Bellinger of Olympus and Dirk. And Dirk, we've had Rob come down a couple of times now.
Yeah, he practically lives here.
He lives here. That's right. He's
should just leave the equipment here in the studio.
We always like doing that. So thank you, Rob, and thank you, Olympus, for sending that down. Thank you all for joining us today. Thank you to Umberto and to Arun for giving us some great articles to talk about on today's show.
Characters.
That's right. That's right. And thank you all again for being here and joining us. So have a great weekend, and we'll see you back here for another week of QDD and QDL next Friday.
So long.
Bye.
Thank you.